Okay, everybody, welcome to Chapter 10. Chapter 10 is circles, and for the first part of this chapter, we're going to be dealing with the standard G.C.2, which is I understand and can apply theorems about circles. So, section 10.1 is lines and segments that intersect circles, and we're first going to start with some definitions and theorems. So, first of all, the definition of a circle is the set of all points equidistant from a given point. And that given point is the center. Okay, now remember, equidistant is exactly what it sounds like. It just means equal distance. So if you're taking a look at the picture of the circle here, we name a circle by its center. So this is circle P, which you can write the word circle and then put P, or you can use that little notation with a circle and a dot in the middle, which is circle P, and then you have everything that's the same distance from that, which makes a circle. Next definition. A chord is a segment, and I'm going to put that in a box, whose endpoints are on the circle. Okay, now keep in mind segment, ray, and line. So if we're looking at a segment, we're looking at something that looks like that. If we're looking at a ray, we're looking at something that looks like that. And if we're looking at a line, we're looking at something that looks like that. So specifically, a chord is a segment. So if you take a look at your picture, it goes endpoint over endpoint, and it just hits the two ends of the circle. That's a chord. Next one we're going to do is secant, and a secant is a line, and again I'm going to put that in a box, that intersects a circle at 2 points. Okay, so if we're taking a look at the picture, a secant is a line, and keep in mind a line is going to keep extending, and it intersects the circle at 2 points. So it's similar to a chord, except for a chord stops versus a secant continues to go. Next one, a tangent or a point of tangency. So a tangent is a line that intersects a circle at exactly 1 point. And that 1 point that it intersects at is called the point of tangency. So if we're taking a look at our tangent line right here would be BA, because it's only going to hit right there at point B, and then point B is the one place it hits. That's your point of tangency. Radius, segment, and again I'm going to put that in a box. It is a segment from center to edge. Okay, and then remember your radius is like halfway, which means 2 radii equals a diameter. Okay, which brings us to a diameter, which is a chord through center of circle. And keep in mind, a chord is a segment, so it has 2 endpoints on the edges of the circle. So it goes from an edge to an edge, but specifically with a diameter, it also has to go through the center. And then keep in mind, 1/2 of a diameter equals the radius. So these two that I wrote here in black and then in blue are the same thing. It just depends how you want to think about it. Keep in mind, if you have a diameter, you can cut it in half to get a radius. If you have a radius, you can double it to get a diameter. We're going to try a couple examples of this and then we'll finish up our definitions. So, identifying special segments and lines. Tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent of circle O. So first of all, notice the notation. Circle O, it's named by its center. Now, letter A, B, C, and D. Do you notice the notation? 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 Okay, that notation is a segment, which means it stops, versus the other notation down here, this is a line. And that's really important because depending on what they put on top of those letters, depends on what you're going to answer. So if I'm looking PR, and they said PR and it stops, I'm looking from P to R. Now it hits on the two ends, it also goes through the center. I'm going to call that one a diameter. Okay, you could also call it a chord, but diameter is more specific and we want to go with the most specific. Okay, keyword best. Next one, MN. Now, notice MN on top of that, they've got the arrows. So now we're talking about a line. If you look at MN, it only intersects the circle once. That's a tangent. PQ also has the line symbol. So we're looking from P to Q, and we're going to keep going. Well, if it keeps going and it extends, it hits it at two places. That's a secant. Now, what if I were to add on here, letter E, and I put P, Q like that? Well, you're still kind of looking at the same thing, but there's a difference. In this case, you would call this a chord because now it stops. It has endpoints on the circles. Okay, last but not least, let's go back to letter D, QO. So let's look at QO, and that one specifically stops. It's not a line, it goes from the edge to the center. That's a radius. Okay, two more definitions before we get started on examples. Tangent line to a circle theorem. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius. And the key word here is radius of the circle at its endpoint on the circle. So, do you guys remember that a tangent is a line, look at the blue one, that only intersects the circle at one point? And the point that it hits is the point of tangency. Well, if you connect the center of your circle to the point of tangency, what this theorem is telling you is that it forms a 90-degree angle. Keep that in mind. Okay, external tangent congruency theorem. Tangent segments from a common external point are congruent. First of all, common, meaning same. Second of all, external, meaning outside. So, external. Then we're going to draw two tangents. So that one hits once there. This one hits once there. Well, if I have two tangent lines that come from the same point, then I know that this line is congruent to that line. That's what that theorem is telling you.